Have you ever just stopped and looked at a landscape and thought about how it got there? I mean, on one hand, you have these incredibly violent, sudden events, a volcano erupting, an earthquake, things that change the world in a blink. And on the other, you've got this super, super slow work of a river just patiently carving its way through rock for millions of years. This incredible contrast, this duel, well, that's the whole story of how our planet is shaped. Okay, let's get into it.
Right here, this is the core tension of geology. You've got this explosive, constructive power that builds things up in a flash. And then you have these relentless, patient forces that spend eons, literally eons, just grinding it all back down. It is a constant tug of war between creation and destruction, and it is happening all around us all the time.
So how in the world do we make sense of this? How do we read the story that's written in every single mountain, every valley, every coastline? Well, it turns out there's a surprisingly simple framework that can explain pretty much any landscape you could ever imagine. And here they are. It all boils down to these three things: force, structure, and time. Force, that's the engine, the energy driving all the change. Structure is the material itself, the blueprint. It's about what the rocks are made of and how they'll react. Are they hard? Are they soft? Are they going to bend? Or are they going to break? And then there's time. Time is the ultimate judge, the one that decides the final outcome of this epic battle. So let's start with the first player in this game, force. So let's meet the builder. Deep, deep inside our planet, the heat from the Earth's core is generating this immense, incredible energy. This is the engine that builds all the big stuff. We're talking continents, massive mountain ranges, the deepest parts of the ocean. It's literally creating the rough draft of our world. These are what we call internal or endogenous forces. Their entire job is to build things up. They're powered by that inner heat, which drives plate tectonics, and that in turn causes the crust to bend, to break, and to erupt with magma. So how exactly does this building process work? Well, one of the builder's favorite tools is folding. I want you to imagine two tectonic plates crashing into each other, but in super, super slow motion. Over millions of years, that constant, immense pressure causes these huge layers of rock to just buckle and bend, creating these massive wave-like shapes. This, right here, is how huge mountain ranges are born. And this comparison is just a perfect way to see the role of time in all this. On the left, you've got the Himalayas. They're young, geologically speaking, and they're still being pushed up. You can see it. They're high, they're jagged, they're super dramatic. The builder is clearly still winning that fight. But then you look at the Appalachians on the right. They're ancient. The building phase stopped hundreds of millions of years ago, and ever since, time has just let erosion take over, rounding them down into what we see today. But here's the thing. Sometimes the stress is just too much. The rocks can't take it anymore. They don't bend, they just snap. This is what we call faulting. It's when rock layers actually fracture and the huge blocks of rock on either side of that break move. And this creates much more sudden, abrupt features in the landscape than folding does. And this faulting can happen on an absolutely massive scale. So when the Earth's crust gets stretched apart by tensional forces, a huge block of land between two faults can literally just drop down. That creates what we call a rift valley, or a graben. The East African Rift Valley is a classic example. But if the crust gets squeezed and compressed, that central block gets pushed up, forming a block mountain, or a horst, like the Tian Shan Mountains. You can see how the type of force, stretching versus compressing, creates completely different worlds. The key thing to remember is that these internal forces, they build that initial framework. But once that framework is built, a brand new artist arrives on the scene, and we call this one the sculptor. These are the external or exogenous forces. They're powered by the sun and by gravity, and they work tirelessly, relentlessly, to carve, to polish, and at the end of the day, to try and level everything that the builder has created. So the sculptor's number one tool is weathering, which is just breaking down rock right on the spot. And the method it uses really depends on the climate. In cold or dry places, physical weathering is the name of the game. Just think of water getting into a crack, freezing, expanding, and acting like a wedge that shatters the rock. But in hot, humid places, chemical weathering is king. Here, water and heat actually speed up chemical reactions that decompose the rock's minerals, kind of like how oxygen causes iron to rust. Now, once weathering has loosened up all that material, gravity takes over, and this is called mass wasting. Sometimes it's incredibly slow.
like the gradual creep of soil downhill that you can only see because the tree trunks are curved at their base. Or it can be terrifyingly fast, like a landslide where an entire slab of the earth just gives way all at once. And the most violent form? That's a debris flow, a destructive, fast-moving river of mud and rock, usually triggered by heavy rain on a steep slope.
Okay, let's put this all together and see these forces in action by looking at a couple of landscapes that have been pushed to their absolute extremes. First up, we're going to look at a case where the builder's power is just undeniable. Volcanic landscapes are the ultimate expression of those internal forces, creating brand new land right before our very eyes.
The key to understanding volcanoes is the magma's composition, specifically how much silica is in it. You see, magma that's low in silica is runny, kind of like honey. It flows easily, and that leads to these quiet eruptions that build up these wide, flat lava plateaus. But magma that's high in silica, that's thick and sticky, more like peanut butter. It acts like a cork in a bottle, trapping gas and building up immense pressure until, boom, you get a hugely explosive eruption that piles up ash and thick lava into that classic, steep cone shape we all think of, like Mount Fuji. And these explosive volcanoes, they leave behind some very distinct signatures. Of course, you've got the crater at the top, which can fill with water over time and form a beautiful crater lake. And then after millions of years of erosion have worn away the softer outer cone, all that might be left is the volcanic neck. That's the hardened magma from the volcano's throat, like the incredible Shiprock Peak in New Mexico. Okay, so we've seen the fire. Now let's shift to a completely different kind of world, one that's not ruled by fire, but by water. This is where we see the sculptor at its most patient, its most persistent, just quietly dissolving entire landscapes from the inside out. Welcome to the world of karst. Now, this landscape is a perfect example of that second secret we talked about, structure. Karst landscapes only happen when you have these thick layers of a specific type of soluble rock, mostly limestone. You see, rainwater is naturally a little bit acidic, and over geological time, this weak acid is patient enough to literally dissolve the rock, creating these spectacular and almost alien-looking terrains. The way a karst landscape evolves is this slow, methodical process. It starts with water seeping into cracks in the limestone, dissolving it and forming little funnels we call sinkholes. Over time, these sinks get bigger and they merge, creating these larger basins. And in the final, most advanced stage, almost the entire landscape has been eaten away, leaving behind only these isolated, steep-sided towers of the most resistant rock. This is what creates the breathtaking scenery you see in places like Ha Long Bay in Vietnam. And what's so cool is that while this surface is being destroyed, a whole new world is being built underground. As that water, now rich with dissolved minerals, drips into a cave, it redeposits the limestone. This is how you get stalactites hanging from the ceiling, stalagmites growing up from the floor, and eventually these massive columns, where a stalactite and a stalagmite finally meet. It's the exact reverse of dissolution, it's deposition in action. So, we've seen the builder, and we've seen the sculptor. These two powerful opposing forces. One pushes up, the other grinds down. But the one element that presides over this entire cosmic duel, the one that ultimately decides the outcome, is time. Time is the final judge. This quote really just sums it all up, doesn't it? The internal forces build the mountains, and the external forces are always patiently and relentlessly trying to level everything back to sea level. The appearance of any landscape that you see is just a snapshot, a single moment in this never-ending cycle. Which brings us to a final, really interesting thought. We see these imposing structures built by these immense powers, sheer cliffs, towering volcanoes, and we also know just how relentless the sculptor's tools can be. So when you look around, which of these structures that seem so permanent, so strong, are actually the most fragile? Which ones are secretly losing the battle against time the fastest? It's something to think about.